In stats today, first day back for the spring semester, we started chapter 7. So we're looking at sampling distributions. That's a brand new term. Statistic is not really a new term, but distinguishing between parameters and statistics is kind of difficult. People tend to struggle with that. So before we dive into sampling distribution, let's look at statistic versus parameter. So parameter, that's something, some kind of measurement like proportion or mean or standard deviation of the population. So I'm interested in this value, and I want to be able to predict it or talk about it. So we go and we take a sample and we calculate that corresponding calculation off the sample, which is called a statistic. So for a parameter, we're talking about things like mu, p, sigma, sigma squared. For a statistic, we're talking about things like x bar, p hat, s squared, and it goes on. We could talk about the population median versus the sample median, all kinds of things. So parameter is off of the population, a statistic is off of a sample. All right, so we want to create a sampling distribution. And a sampling distribution is where I hypothetically take a sample over and over and over again, ideally infinitely, and create a graph of all of those samples and their statistics. So I found this website, or I heard about this website. By the way, there's our notation there that I just now talked about. But I found this website that really demonstrates it well, I thought. These guys, they made this little program based on Reese's Pieces, and we're going to check it out. So when we go to that website, it takes us here. And then click Reese's Pieces up here under Sampling Distributions. And this is the default. And if you go to my handout, I ask you to change some things. So, I ask you to change it to 0.45. Right now it's at 0.5. So if we were to look at a distribution with a proportion of orange candies of 0.5, this thing would be very bell-shaped, it'd be very symmetric. Let's try and show how maybe if we create an off-center distribution, something interesting happens. So I changed that to 0.45, and by the way, in the notes, I talk about pi versus p. I think on that website it uses pi, and that resembles the true proportion or the parameter. And then they use they use p hat to symbolize the statistic, which is what we use, and that's a proportion of orange based on the sample. So I ask you to keep it at 25, and it's already at 25. Right now I'll leave the animation on. Let's change this to proportion of orange, and let's draw a sample. This is going to do one sample of 25 candies. And they got a sample proportion of 0.24, way below 45. Remember, this was one sample. Let's do another one. That one was very close to 45. It was 0.44. Let's turn off the animation, and let's do this a bunch of times. I'm going to do it 100 times. And we have a nice bell-shaped distribution. Those dots right there, that resembles a sampling distribution. Each dot is a p hat. So that is crucial. If you're struggling with those definitions that I typed in the notes, this is a sampling distribution. of p hat. Each dot, this concept right here, hopefully explains it, represents a p hat. Because if you look top left, we did this 100 times. Took 25 candies, got p hat. Took another 25 candies, got another p hat. So every dot resembles a sample. So this is this collection of dots is called a sampling distribution. Hopefully that makes sense. Something really cool happens when you move through the questions that I ask in this handout. I ask you to adjust some things. So we only bumped it up to 10, and here we bump it up to 400 trials. But down here, I ask you to change the sample size. So change it to 50. Let's see what happens when we do that. I'm going to hit reset so we get a new picture. So maybe take a mental picture of that. Hit reset. Ooh, very different. If we keep drawing samples, something interesting should happen. Let's do 1,000 here. It should be as we take more and more samples, it should approach the bell curve. Look how perfect that one is. Very interesting that we had a kind of off-center distribution, and now it's perfectly bell-shaped. Down here, I ask you to take it down to 0.15. So I'm going to change, let's hit reset. Change it to 15. I'm going to knock that. What did I say to change that to? I think I left it at 25. I'm going to take that sample size down to 5. And we're going to do it a lot of times. So in this candy machine, there's only 15% orange. I'm going to take a small sample of 5, but I'm going to do it 10,000 times. I get a very right-skewed distribution. Most of the time, I'm getting 0 orange or 0.2 orange. And then, if I increase my sample size to, say, 50, hit reset, it just forced that positive skew distribution to a symmetric bell-shaped distribution. And notice the mean right here is 0.15, and the true mean is 0.15. It's this cool characteristic that happens with sampling distributions. All right, feel free to get on this website and practice and experiment. I ask you to make some conclusions, especially on number 7 right here, about sampling distributions. It's a rule that we're going to write down eventually in these notes, but I just wanted you to do some trial and error and maybe derive it yourself. All right, let's back up and let's practice terminology. So maybe hit pause and read, and we're going to answer these. I would say in this one, the population is residential telephone numbers in a large city. Oops. Some people make the mistake of talking about unlisted numbers or 48 or 52%. This population is just the group that I'm sampling from. And I'm sampling these numbers in a large city. I haven't measured anything yet. That's just my group. The parameter is the measurement I'm interested in. I am interested in P, the true proportion residential telephone numbers in a large city that are unlisted. And we know that proportion. Is it 48 or 52? It is 52. All right, the sample, we took 100, let's say the first 100 random telephone numbers. Once again, this is just a sample. What did I sample? Sampled those 100 numbers. This isn't a measurement, a statistic. The statistic is the proportion of unlisted, 0.48. The sample proportion of unlisted numbers. All right, I hope that made sense. We're going to practice this more tomorrow. I will see you later.